Yes, good morning, my dear students. Now, in this video, I'm going to solve some problems related to the electric dipole. Here, three category of problems are not solved. One is potential energy, U equal to minus PE into what? Cos theta. This problem. Problems related to the potential energy. This is the scalar quantity. Energy is a scalar quantity, P dot E. That is, in the scalar form, we are writing what? U equal to minus PE cos theta. This is one problem. Second one, what is the work done in rotating the dipole? He will ask the question like this: equal to P into E into cos of theta 1 minus cos of what? Theta 2, where theta 1 is initial angle, that is initial angle, then theta 2 is final angle after rotation, final angle after a rotation, that is after a rotation. Problems are very simple ones. Third category of problems, what is the force acting on the dipole? It is placed in the field like that. What is the force acting? F equal to what? P into what? dE divided by what? dx. Change of electrical field with respect to what? Distance. Students, whenever if you use the term electric field, it changes, along x, along y, whatever. At the time, you should write dE divided by what? X, you have to write. How this equation comes, I'll tell you. We know that force equal to what? Charge into what? Electrical field. This is Q divided by distance, I am writing, dimensionally I am writing, into E into what? X, I am writing. You see, this charge multiplied by this distance. Yes, 1 minute. This charge multiplied by this distance is nothing but dipole moment. Then next, this quantity is nothing but dE divided by what? dx. This is how the formula arrived. I hope that you understood this one. Sorry. Remember, one set of problems on the what? Potential energy. Second set of problems related to the what? Work done. Third set of problems related to the force. Okay. Now I will start one by one. That is, I will start now. Okay. Okay. Read the question. Sorry. In which of the following states the potential energy is maximum? This is asking. He is asking where the potential energy is. What? In which figure potential energy is maximum is asking. Come to the diagram A, that is choice A. You see, electrical field is here, but dipole moment is like this. That is P cap. You see, dipole moment is acting in this direction. Electrical field is acting in this direction. That means theta, not like this, E bar, it is what? Here, both are acting in the what? Opposite direction. So that theta equal to what? 180 degree. You know the formula for the potential energy. U equal to minus PE into what? Cos theta. Now I'll substitute. U equal to minus P into E into cos of what? 180. What is cos of 180? Minus 1 minus P into E minus of 1 equal to PE. This is for potential energy. Now let us check it. This is for the diagram A. For the B, leave it because some angle is there. Always should check for the extreme angles. For this you check it. For the choice C you check it. Here dipole moment direction is like this. Electrical field is like this. What is the angle between them? 90 degree. Here theta equal to what? 90 degree. Therefore, cos 90 equal to what? 0. Then potential energy equal to minus PE into 0. Then U equal to what? 0. Okay. Let us check for this diagram. Dipole moment is in this direction, from negative to what? Positive, P cap. Electrical field is also in the same direction. In this diagram, you see, both are acting in the same direction. So that theta equal to what? 0 degree sine of 0 equal to what? Sine of, not sine of 0, cos 0 equal to cos of 0 equal to what? 1, that is. I don't want this sine term. Then U equal to minus P into 1, U equal to what? Minus P into what? You see, here the negative quantity is there, here it is positive quantity. Positive quantity is what? More. It is for the diagram what? 1. So that this is the what? Right answer. Okay. I would hope that is clear for you guys. Next. Second one, read the problem. That is, an electric dipole has a magnitude of its charge is q, that's the magnitude of charge is q, and its dipole moment is what? P. It is placed in a uniform electric field E. If its dipole is placed along the direction of the field, that means theta equal to what? 0 degree, that is along the direction. Means I'll tell you like this. These are the uniform electric field. Assume that it is from left to what? Right. Next, here it is negative charge and this is what? Positive charge. So that dipole moment is also acting in the same direction. So that electrical field and dipole moment both are acting in the same direction. So that theta equal to what? 0, that is. Okay. If dipole is placed along the direction of the field, the force acting on it. Okay. Here, whenever the dipole is placed in the uniform electrical field, when dipole is placed in uniform electrical field, you see, the force is acting like this, force is acting like that. Both how they are? Equal and opposite. So that F net equal to what? 0. I will solve it once again. This is negative charge. This is what? Positive charge. Your electrical field is what? Like this. So that this must be positive, this must be what? Negative. So that negative charge is attracted by like this. F equal to what? Q into this is negative. So that this is attracted by this. F equal to what? Q into E. How they are? Equal and opposite. Equal and opposite. So that net force equal to what? 0. He is asking for the force and also what? Potential energy. You see? 0. Force is 0 means only this choice is there. No this, not this, not this. This is the what? Right answer. If you want to check for the potential energy, potential energy equal to minus P into what? Cos of what? Theta. U equal to minus P into cos of what? 0. Cos of 0 equal to 1. U equal to what? Minus of what? P. This is minimum, that is minimum potential energy, that is. So that 100% this answer is what? Correct. Next, if electric dipole is placed in a uniform electrical field, no, only what? Torque is acts on it. That you know that. In uniform electrical field, in a uniform, I told you several times, in a uniform electric field, here, two motions. One is translatory and another one is what? Translatory. Yes. And another one is what? Rotational, that is. Rotational motion, that is. Here, this is okay. Rotational is there. But no translation. Why? In the previous problem, I told you F net equal to what? 0. So that taught okay. Next, a dipole moment of dipole 6.4 into 10 to the power of minus coulomb meter. You write P equal to 6.4 into 10 to the power of minus 9 coulomb meter. electrical field equal to 5 into 10 to the power of 4 volt per meter. Because it is a kilo, no? Kilo means we can write 50 into 10 to the power of 3 equal to 5 into 10 to the power of 4 volt per meter. What is the amount of rotating the dipole from equilibrium position to what? 180 degree. Initial position theta 1 equal to what? 0. Whenever he said that equilibrium means theta 1 equal to 0, then theta 2 equal to what? 180 degree. I told you this several times. This is your electrical field. This is your electric field. Okay. Dipole, this is negative charge. This is what? Positive charge. You see, direction of dipole moment is like this. Electrical field is like this. Both are acting in the same direction. So that theta 1 equal to what? 0. This is called as equilibrium position. That is what? Equilibrium position. That is. Now it is rotated through what? 180 degree. What is the work done? Amount of work done. Which formula? Work done equal to P into E into what? Cos of theta 1 minus cos of what? Theta 2. Substitute. Work done equal to P into E into cos of 0 minus cos of what? 180. That is. That work done equal to P into E into bracket 1 minus minus of 1. This is equal to 2P into what? E, that is. Yes. Substitute. P value is given here. Work done equal to 2 times P value. How much it is? 6.4. It is 6.4 into 10 to the power. How much? Minus of what? 29. No need to conversion. And 5 into what? 10 to the power of what? 4. 5 into 2. Work done equal to what? 10 into what? 6.4 into 10 to the power minus 29. And this one, I think there is some mistake here where my typing 4, no 4, 1. Now this is minus of what? 25 it is. Okay. This means equal to 6.4 into 10 to the power minus of what? 24. 6.4 into 10 to the power 24. This is the what? Right hand side. This is in what? Joules. Okay. Next. Come to this point. Due to an electric dipole shown in figure, electric intensity is parallel to dipole axis. Dipole axis at P only, at Q only, both P at Q, and neither P and Q has given this. Okay. Dipole axis. Okay. This is negative charge. This is your positive charge. This is called as a dipole axis. Dipole axis. Here he consider the point P. He consider point. You see, for the positive charge, electrical field is E. For the negative charge, it is like. But resultant field is acting like this only. As you know that in the axial line. In this point P lies in the what? Axial line. Okay. In case of axial line, E is parallel to dipole axis. Good. Okay, fine. Okay, at P it is okay. What about at point Q? That is, he considered this is the point Q. This is the point Q. For the negative charge, remember, it is inward. For the positive charge, it is what? Outward. And resultant of this is what? Like this. It is E of what? Result. Here also, you see, this It is parallel to or anti-parallel to what? Dipole axis. It is possible even in case of Q. This is the point Q. Even it is possible in case of what? P, parallel. So that both at P and Q, that is. Actually, you should represent parallel or anti-parallel. That you should represent. Right. Okay. Next. The ratio of electric field due to an electric dipole on the axis of an equator line at equal distances will be on the axial line and also what? Equatorial line. It is 2 is to what? 1. Recall your formula. E of axial equal to what is that? Constant K into what? P divided by R cube into what? 2 is there. 2P added. For the E equatorial, that is E equatorial equal to K into P divided by what? R cube. In the class hours I did constant K is nothing but 1 divided by what? 4 pi what? Epsilon naught. Compare it to this equation. You see, this is nothing but E equatorial. Can I write like this? E of axial equal to E of equatorial multiply by what? 2, that is this equation. And then E of axial divided by E of what? Equatorial equal to 2 by what? 1, that is. Or else sometimes they may ask you E of equatorial divided by E of what? Axial equal to what? 1 by 2, that is. One important point you have to consider here, in both cases comparison, R should be same, students. R should be what? Same in both cases. Then only it is possible. Suppose if it is R is 10 centimeter, here also 10 centimeter. If it is 15 centimeter, this also what? 15 centimeter. Okay. Already we did that. Okay. A dipole of dipole moment P is placed in a uniform electric field of strength is E. If theta is the angle between positive direction of P and D, then the potential energy he is giving, that is what? It is like this. This is your electrical field and this is the what? Dipole moment, that is what? Positive direction. This is what? Theta. Then you know that. Then he is asking U equal to what? Minus of what? PE into what? Cos theta. You know this equation. Okay. Now, if theta is the angle between positive direction of P and what? E is asking, then the potential energy equal to what he is asking. It is. Let's do it. Potential energy in the direction. It is if theta is the angle between the positive direction of P and E, then the potential energy of the electric dipole is largest. Oh, I have not read this one. That means maximum. That is largest means what? Maximum. Already I did here. U is maximum. He is asking. U is maximum. You read. You should read carefully. That is largest. Largest means theta equal to what? 180 degree. So that U equal to minus P cos of what? 180. What is cos of 180? Minus of 1. P into E minus of 1. U equal to what? Plus P into what? E. This is the maximum. So that theta equal to 180 degree. Next. An electric dipole is placed in a electric field generated by a point charge. Remember, students, point charge concept is concerned. Point charge gives a uniform electrical field or non-uniform electric. It always gives non-uniform electric field. Non-uniform electric electric field. No uniform electric field. Why? We know the equation E equal to K into Q divided by what? R square. If R is different, then electric intensity is also different. You see, this is your charge plus Q. At this point, you see, distance is what? Varies here. As distance varies, E is also what? Varies. It means, indirectly he said that, it means dipole is placed. Please understand. It means dipole is placed in which field here? Placed in a non-uniform electric field. Non-uniform electric field. We know that in the non-uniform electrical field, in this case, F net is not equal to what? 0. That is not equal to what? 0. Of course, torque is there. So that must be 0. Wrong. This is torque. Then torque of the dipole due to the field must be 0. No. It may be 0 because torque equal to P into E into what? Sin theta. It may be, I don't know the angle that is. If theta equal to 0, then sin 0 equal to what? 0. Then torque equal to what? So please answer carefully. It may be 0. I don't know the angle between P and E, that is. That's why this is the right answer. The torque on the dipole due to the field may be what? 0. That is the right answer. Next. The force between two short electric dipoles, okay, separated by distance R is proportional to electric dipoles separated by distance R is proportional to, I told that F equal to P into what? Into dE divided by what? dx. I told this force. Here you say F equal to P into d by dx or d by dr, we can say that. On the axial line or on the equator line, E is directly proportional to what? 1 by r cube, I know that. So that this is 1 by r cube, that is. Remember students, in dipoles, E is directly proportional to 1 by r cube. In a point charge, but in a point charge, E is directly proportional to 1 by r square. Please note down the difference. Make out the difference. So that F is directly 1 by r cube. That means it is a d by dr of what? R to the power minus 3. F is directly proportional to minus 3 into r to the power of what? Minus 4. So that F is directly proportional to what? R to the power 4 here. R to the power 4 or R to the power of what? Minus 4. This is the right choice. Next. Two electric dipoles are placed as shown. Okay, dipoles is not, figure is not correct. Now I will represent like this. This is minus charge. This is what? Positive charge. Okay. This is dipole 1. It produces the electrical field in this direction, that is along the axial line. Okay, fine. He is asking energy, potential energy is asking. Here another dipole is there. This charge is minus, this charge is plus. So that direction of the dipole moment is from negative to what? Positive. This is P2. This angle is what? Theta, that is. You know the equation U equal to minus PE into what? Cos theta. Can I write like this? Minus separate P into cos theta into what? E I am writing. That means component of B2, that is component of P2 in this direction is, that is, we know that, along x direction. This will be P2 into what? Cos theta. However, electrical field is acting like this. Then you write it here, U equal to minus of what? P. That means P2 I am writing. P2. Okay, cos theta I am writing. Electric field of which dipole? Dipole 1. Along what axis? Axial line. For the axial line, we know that K2 into P1 divided by what? R cube into what? Cos of what? Theta. Then you see U equal to minus 2K P1 P2 into cos theta divided by what? R cube. That is, this is the right choice. Okay, fine. Next, electric field on the axis of a small electric dipole at a distance R is, read carefully, R is what? E1, and E2 at a distance 2R on a line perpendicular bisector. This is what? Axial line. Please understand. For axial line, it is E1 has given. Distance is R. Distance is R. Okay, fine. Next you see, perpendicular lines means what? Equatorial line. Equatorial line. Equatorial line. This is E2. Distance is what? 2R has given. That is okay. Normally we'll apply this students, E of axial equal to what? 2 times of what? E of what? Equatorial we are applying. This we would apply when in both cases distance is what? R only. Otherwise should not apply this. Okay, fine. Here you have to, this is R now. I want to calculate the axial line. E on axial line. Or at a distance of what? R you have to calculate. How to calculate? E is directly proportional to what? 1 by R. So that E dash divided by E equal to R cube divided by 2R cube, whether you followed or not, I don't know this. Because I want to calculate at what distance here? 2R I have to calculate. E dash. This becomes R cube divided by 8R cube. That means this E1, that is what? E1 equal to, how much it is? E1, not E1, E dash equal to E1 divided by what? 8. It is not E1, now it becomes what? E1 by what? 8. I would hope that if problem. This is equal to 1 by 8. Therefore, E dash equal to, this is E1 equal to E1 divided by what? 8. No. Okay, fine. Now you can apply it. Here, E of axial equal to 2 times of what? E of what? Equatorial. What is E of axial? E1 by 8 equal to E of equatorial has written 2 of what? E2. That is okay. I want E2 by E1 or something. Therefore, E1 by E2 equal to 16, or E2 by E1 equal to 1 by what? 16. 1 by 16. This is the right answer. Yeah. Here the negative sign Y represents is, in case of equatorial line, in case of, go through the theory part. In case of equatorial line, electrical field is in this direction and dipole moment is what? In this direction. So that theta equal to 180 degree comes here. Both are negative is there. In the theory part, you both write. Clear? I hope that is clear for you guys. Here, whenever we want to compare now, both distance should be what? Same. But in this problem, this is R is there, this is 2R. So that I am converting E axial at a distance 2R, I am converting. At 2r, it is even by what? 8 here. Okay, next. 2-point charges plus q and minus q are held at minus a comma 0 and a comma 0 respectively of xy coordinate of the system. Okay. Now, choice are electrical field at all points on the x-axis. E at all points on the y-axis is along I. Along I means what? X-axis. This means what? X-axis. Okay. Positive work is done in bringing a test charge from infinity to the origin. Of course, it is not at all related here. That is. Next, all the above, that is. Okay, fine. I will draw the diagram. This is 0 comma what? 0. This will be minus a comma 0. This will be plus a comma what? 0. Which are the charges placed here? Plus q. Here it is plus minus q. Along y-axis, you check it. This is the electrical field. For the negative charge, this is the electrical field. This is the what? E of what? Resultant. E of resultant, it is acting parallel to the dipole axis, that is parallel to x-axis. X-axis means what? I cap. So that this is I cap. This is the what? Right choice. Now